JAMB Expo questions and answer session, knowing fully well that we are just left with one day to our JAMB exam. Today is the Tuesday, the third day in the month of April 2025. We are just left with less than 20 hours or even 15 hours for our JAMB UTME. So what we will be doing right now is to touch topic by topic. That is what we'll be doing. We'll be answering past questions based on topic by topic, and I believe you are really going to enjoy this interactive session. So you are welcome again to another edition of our made was simple. So this is our chemistry made simple. JAMB Chemistry, JAMB Chemistry Revelation Hour. This is our JAMB Chemistry Revelation Hour. So this is our JAMB Chemistry Revelation Hour. Let me look for marker. So in our JAMB Chemistry Revelation Hour today, we'll be focusing on bringing in topics, questions that are very, very essential. Questions and topics that are very, very essential. So basically, the number one question we have here is on nature of separation. We have nature of separation, nature of matter. We have nature of matter and separation of what? Mixtures. That is how our question is going to stem from. So we go on with the first question. The first question says, which of the following is a physical change? Which of the following is a physical change? A. Adding ion fillings to a red water. Adding ion fillings to aerated water. B. Adding sodium metal to water. This is B. This is A. B. Adding sodium metal to water. Adding sodium metal to water. And C. Cooling a solution of iron 2 sulfate to obtain the hydrated salt. Is plenty. And D. We have cooling of water to obtain. And E. Burning of what? Domestic what? Gases. So that is what we are going to do. This question today is based on nature of matter and separation of mixtures. We'll be touching these different what? Topics. So which of the following is a physical change? The question here is based on what? Physical what? Changes. So the option here says what? A. Adding ion fillings to aerated water. B. Adding sodium metal to water. C. Cooling a solution of iron 2 sulfate to obtain hydrated salt. D. Cooling water to obtain what? Ice. Cooling of water to what? Obtain what? Ice. And E. Burning of what? Domestic gas. That is what's known as what? The utility what? Gas. Our answer there is going to be what? D. Which is what? Cooling of water to obtain what? Ice. Note. Any change of state is a physical state. Any change of state is a physical what? Changes. Anything that involves changes of what? State is what? A physical what? Change. So let me give you the rundown of this what? Change of what? States. We have our what? We can say we have our what? Liquid. I don't know whether we are seeing this marker. Saying this marker is not good. Yes, we are having our what? Liquid. We are having our what? Solid over here, and we are having our what? Gas. So when it involves what? Change of state, we are going to have something like this. You understand? We are going to have an arrow going up. We are going to have something like this, and we're also going to have something like this, and also our arrow was going what up. So let's fill in this word, change the word state. Let me check whether I have another marker, if there's anybody following up the class. All right, there's someone following up the class, and I hope you can see. Let me check whether you can see. Okay, you're actually seeing what I'm doing. So when a solid changes to what liquid, when solid changes to what liquid, it automatically means what melting. So we say here what melting. When solid changes to liquid, it turns to what melting. Then when liquid turns to what solid, it is what freezing. So what freezing. So solid going to what liquid is what freezing, and liquid coming to solid is freezing, and solid going to liquid is what melting. Then when liquid turns to what the gaseous state, when liquid goes what to gaseous state, it is known as what vaporization. That's what we say what vaporize. So from liquid to gaseous state is what is known as what vaporization. So from liquid to gas is what is known as what vaporization. And from gas to liquid is when gas turns to what liquid, it is known as what condensation. So we say what condensation. So from gas to liquid is known as what condensation, and from liquid to gas it is known as what vaporization. Then we have from solid to gas, because gas cannot turn from gas to solid. It's not possible. But we have our word solid turning directly to what gas. Exactly the word iodine. So when solid turns directly to gas, it becomes what, or such a change of state is known as what sublimation. So it is important to note this key point that I just mentioned here, that anything that involves change of state, anything that involves what a change of state is what a physical word change. Anything that involves what a change of state is what a physical word change. So these are examples of what a physical word changes. These are examples of what physical changes. So our answer there is going to be what D, which is what the cooling of what water to get what ice. You cool water in order to what obtain what ice. The examples of chemical changes, we have a lot of examples of what chemical word changes. So when it comes to what chemical word changes, new substances are what formed. When it comes to what chemical changes, new substances are what formed. Example, like the burning of wood. Let's assume this is a pepper and I burn this pepper. I cannot get back this word pepper, but rather we are going to get what is known as what ashes. You understand? We are going to get what ashes. So the burning of wood is an example of what a chemical word changes, because new substances are what formed. But when it comes to what physical word changes, no new substances are what formed. So we also have an example of a chemical change, like the what slaking of what lime. We also have what passing steam over what red hot iron or what coke. So let's go on to the next question. The next question says, by means of filtration, what component can be obtained pure? By means of filtration, let me see how many people are in the live class. We have 2 people right now. Thank you for joining the live. So the next question there is, by means of filtration, one component can be obtained pure. Every word on the word pure. One of the components can be obtained pure from an aqueous mixture of sodium chloride, and which the question there simply means, if we want to filter, what component can be obtained pure from an aqueous mixture of sodium chloride and air. So we want to obtain a pure sample in a mixture of sodium chloride, and which other compound or element they are talking about? We say what? A, potassium nitrate, A, potassium nitrate. We have B, sand. We have C, lead nitrate. And we have D, sugar. And we have D, which is what? Starch. Sorry, we have E. Sorry, we have E, yes, which is what? Starch. So the question is, which infiltration, where or which sample can we remove what? Pure, when sodium chloride is what? Is with this particular what? Sample. So that is what? Our question, right? So the answer there is going to be what? B, which is what? Sand. Note, what we are looking for is what? They are in what? A solution. They are in what? Aqueous or solution. That means that there is water is what? Involved. So when you talk about what? Potassium nitrate will dissolve. But when it comes to sand cannot be what? Dissolved with what? Salt. In fact, sand, it cannot dissolve what? Sand. You understand what I'm saying? But salt will be what? Dissolved. So in order for we to get our what? Pure sample, emphasis on what? The pure. So for we to get the pure sample, what we simply do is what? To filter off this what? Sand. So the answer there, in order to get a pure sample, it is going to be what? Sodium chloride and what? Sand. Because sand is insoluble in what? Water and can be what? Filter what? Off. The next question here, it says, the next question, one of the following technique can be used to show that chlorophyll pigment. Let me give you the answer. Let me check how many people are currently in the live. Let me give you the answer. All right, I have someone still in the live. The moment you hear, when it comes to chemistry, I've been talking about this point. The moment it comes to chemistry and you hear anything like pigment, the moment it comes to chemistry and you hear anything like pigment, you hear anything like spit, or anything like migration, speed migration, rate of migration. You hear anything like dyes. You hear anything like color. You hear anything like ink. Please note that the only separation technique that can be done when it involves a pigment, when it talks about what? Speed or migration, when it talks about dyes, when it talks about color, and we talk about ink, is known as chromatography or chromatography. It is known as what? Chromatography. Chromatography. So chromatography is the word separation technique that involves, so when you hear about what? Pigment, speed, dyes, color, and what? Ink. So reading from this question that I have here says, one of the following techniques can be used to show that chlorophyll pigment is a mixture of chemical compound and not a single color compound. Take note, you have heard the word pigment and you have heard the word color. So let's get the option. We say what? A, crystallization. Crystallization is used to get what? Pure what? Samples or pure compounds. So it's not going to be what? Crystallization. B, we have what? Hydrolysis. It cannot be what? Hydrolysis. We have C, sublimation. It cannot be what? Sublimation. Because sublimation, we are talking about what? From what? From the solid directly to what? The gaseous state. But this is not what we are asking about. What we are talking about is what? Separation technique when it comes to what? Pigment and what? Color. And we have what? D, filtration. And we have E, which is what? Chromatography. The answer there is what? Chromatography. That is just what I said. I said the moment you hear separation that involves ink, that involves pigment, that involves speed, that involves color, dyes, please know that it is what? Chromatography. It is important that you get this key point because JAMB exam is just tomorrow. There is not much time left for you to start cramming. It is very important that you just get the breakdown and what? Leave the word rest. The next one again we have is, alright, the next one again you have, which of the following compound and element will sublime? Which of the following compound or element, which of the following compound an element will sublime? Emphasis on the word known as what? Sublime or sublime. That is where the emphasis is. So which of these elements will sublime? On exposure to the atmosphere. On what? Exposure to the what? Atmosphere. First of all, you have to understand what is what? Sublimation. Where this word is what gotten from. So when you get the meaning of what sublimation, then that is where you what continue what reading. You say what? A, ice. You say what? A, what? Ice. We say B, sulfur. B, sulfur. We say C, phosphorus. C, phosphorus. And we say D, iodine. We say D, iodine. And that is just it. If we look at the answer, remember when I gave you that changes and I talked about what sublimation. The only element I mentioned when it comes to sublimation is what? Iodine. So iodine is the only what element that was sublime in exposure to the what? Atmosphere. It is not going to be what? Ice. Because when ice is exposed to the atmosphere, what is simply going to do what is to melt. Rather, is it going to be what? Sulfur or what? Phosphorus. So the answer there is what? Directly what? D. So that is just it. Let's check on the next question. Let's check on the next question. It says sodium chloride. That is the next question. Sodium chloride may be obtained from brine solution. From a brine solution. So you have to ask yourself, what is what a brine solution? Sodium chloride can be obtained from a brine solution by A, titration, B, decantation, C, distillation, D, evaporation, and E, sublimation. So in which of these can we get what? Our what? Sodium chloride, or our what? Sodium chloride can be what? Obtained from what? A brine solution. How can we get our salt when it comes to what? A brine solution? Is it going to be titration? Is it going to be decantation? Is it going to be distillation? Is it going to be evaporation? Or is it going to be what? Sublimation. So our answer here is D, which is what? Evaporation. Our answer is what? D, and my marker is bad. I wanted to buy marker. Our answer is what? D, which is what? Evaporation. Now, take note of this word explanation I want to what? Give. Take note of what explanation I want to give. Remember I said what is brine what? Solution. That is the first question I said. What is what a brine what? Solution? A brine solution is simply a solution of what? Sodium chloride plus what? Water. That is what a brine solution is. This is known as what? Brine what? Solution. Brine what? Solution. So a solution of sodium chloride and water is what is known as what? Brine what? Solution. So how can we get our what? Sodium, our salts from what? When it is what? Dissolved in what? Water. If you check the answer here, we have what? Titration. It cannot be titration. It cannot be what? Decantation. It cannot be distillation. Just it's already what? Dissolved. It's what? A soluble what? It's a solvent. Sorry, it's a what? Solute that is what? Dissolved in the what? Solvent. So it cannot be distillation. It cannot be sublimation. Rather, the answer is what? Evaporation. The answer is what? Evaporation. Now, why do we say what? Evaporation? Now, sodium chloride is what? Gives what? Resistance. Hence, they use what? Evaporation to heat the water. You understand? They heat the water because we want to get our what? Salt. So the only way is to what? Evaporation, and is to what? Apply heat. When you dissolve salt in water, the only way for you to get back the salt is to what? Heat our what? Our water to heat the solution, right? Heat the solution, and the water is going to what? Evaporate, leaving us with our what? Salt. Leaving us with our what? Salt. Now take note. The salt that is remaining when you heat water to dryness is known as a anhydrous salt. The salt remaining after evaporation is known as what? Anhydrous salt. It's known as what? Anhydrous salt. If you don't want to call it the anhydrous salt, it can also be known as what? An amorphous salt. Amorphous salt. It can also be known as what? An amorphous salt. Now, what is what amorphous salt? An amorphous salt is a salt with what? An irregular structure. It's one in which the word structure has been what? Destroyed. So that is what that's how we can be able to get our what? Salt, which was sodium chloride, from what? A brine was solution, which is a solution of what? Water and what? Salt. So we heat our salt to what? We heat our water to what? Dryness, and we will get our remaining salt, which I said the remaining salt is known as what? Anhydrous or what? An amorphous salt. So let's take on the next question that is what there. It says, which of the following, next question, because we are focusing on nature of matter and separation of what mixtures. Before we move on to the what next what topic, we are touching them what question topic by what topic. The next question is this: which of the following is an example of what a chemical change? Which of the following is an example of what chemical what changes? Which of the following is an example of what a chemical what change? We say A, the solution of salt in water, the dissolving of salt in water. Is it a chemical change? No, it is not what a chemical change. Well, no new substances are what form. If I want to get back my salt, I can easily get back my what salt. So the moment you can easily get back the what substance, it is no longer what a chemical change. Rather, it is what a physical what state or a physical what change. The next question, it says rusting of iron. That is B. Rusting of what? Iron. We have the next question, the next option. C. Melting of ice. And D. Separating a mixture by what? Distillation. What do you think is going to be our answer? Our answer is simply going to be what? The rusting of what? Iron. Our answer is simply going to be what? The rusting of what? Iron. Imagine your iron being what? Getting what? Rust, right? When the iron gets rust, that is simply what? A chemical will change. Because the moment the iron gets rust, it becomes what? Brittles, right? It becomes what? Brittles, and can easily be what? Destroyed. And we cannot get back our iron in the what? Original what? State again. The moment it will get what? Rust. And you know that rust, please take note, rust is fastly. This network is bad. Alright, so the question is this: how can we prepare what? Nitrogen and oxygen in the what? Industry. How can we prepare what? Nitrogen and oxygen from the what? Industry. So you have seen the option there. Say what? A, rate of what? Their diffusion. B, based on their what? Solubility. C, based on their density. And D, based on their what? Boiling point. Note that oxygen and nitrogen is a component of what? Air. The oxygen and nitrogen is a component of what? Oil. How can we prepare what? Nitrogen and oxygen in the industry from what? Air. How can we prepare them for what? Air. A, based on their rate of diffusion. B, based on their solubility. C, based on their density. And D, based on their boiling point. Note, oxygen, nitrogen, these are all components of what? Air. So the only way we can separate them is a concept that is known as what? Fractional what? Distillation. We can only separate oxygen, or we can only what? Prepare what? Oxygen industrially from air in the concept that's known as what? Fractional what? Distillation. And we can also prepare nitrogen industrially from air known as what? Fractional what? Distillation. And this is based on the what? Boiling what? Point. This is based on the what? Boiling what? Point. So the answer there, the preparation of nitrogen and oxygen industrially from air is not what? The rate of diffusion, neither is it the solubility, neither is it the density, but the answer is what? D, which is the what? Boiling what? Point. That's what, bro. Yeah, sir. Welcome. So that is just what it. The rate of diffusion is not the answer, it's not the solubility, it's not the density, rather it is based on the what? Boiling what? Point. So the next question there, let me just list out this separation technique, because I get to find out that We are not going to waste much time in the separation technique. So I will just list out what you are supposed to know in terms of separation technique. I will move on to the next topic immediately. So let's write the separation technique and the particles or the property it will exhibit. So we say separation technique or the separating technique. We say separating technique. Separating technique. And the property they will exploit. Property will exploit. The separation technique and the property they will exploit. Number one, we have is what the first separation technique we have is what is known as what sieving. The first separation technique we have is what is known as what sieving. Sieving is a type of separation technique that involves the separation of different particles based. Sorry, I just mentioned it. It's based on their separation of different particles based on their sizes. So we say different particles, different particle sizes, different particle sizes. You came to it. Yeah. So different particle sizes. So that is what separation that is a sieving, a type of separation technique. Please note, I saw a question where they said sieving is a separation technique that involves same sizes, big sizes, little sizes, and different sizes. The answer there is what D, or the answer there which I got was what D, which is what different sizes. So that is just it. That is just it. That is what number 1. Then number 2. Separation technique is what is known as what fractional distillation. I just want to give you the separation technique so we can move on immediately to the next topic. It's known as what fractional distillation. Fractional distillation. So for the fractional distillation, the property or what it actually involves itself in is what is known as what the differences in the boiling point, which I talked about the nitrogen, I talked about the oxygen, and you can also get petroleum product or petroleum, right? You get the cooking gas, you get our fuel, you get our kerosene. So what the property they exploit is based on what differences in what boiling point. Differences in what boiling point. That is when separation, a separation technique known as what fractional distillation takes its hold. The next separation technique I have here is what is known as what the fractional crystallization. Please note, the fractional distillation is totally different from what fractional crystallization. So we show what fractional crystallization. Fractional crystallization. So the moment I mention crystallization, you are supposed to already start getting this idea, because I'm mentioning crystals. I want to talk about crystals. We are talking about their solubility. When we talk about crystals, we are simply talking about solubility. So the fractional crystallization takes its effect based on their differences in solubility. There are differences in solubility. How the solubility of salt. No, salt is a crystal. The solubility of sugar. So these are all crystals. So what or how we can be able to separate them is based on their differences in solubility. How they can be able to dissolve in different solvents. So say differences in solubility. Differences in solubility. So that is what fractional crystallization is. So let's check up the next one, which is the sublimation. Sublimation. We have sublimation. So for the sublimation is just the ability to sublime. Ability to sublime. Ability to sublime. So we already know what sublimation is, right? When a solid turns directly to gaseous state. Example is iodine. You understand? One of the examples we have is our iodine. So the ability for them to sublime, that is how we can be able to separate these different components if they are together. How we can be able to separate them is that if one of them can be able to directly turn into the gaseous state. So we say solid to solid to what? Gaseous what? State. Instead of going from solid to what? Liquid, that is what? Melting. And from melting to what? Directly to what? Gases, which is what? Vaporization. Rather, it goes what? From solid to what? Gas. So the ability for them to supply is how we can be able to what? Separate them using this what? Separation technique that is known as what? Sublimation. So we move on to the next word, which is what? What? Magnetic what? Separation. Magnetic what? Separation. Magnetic what? Separation. So when it comes to what? Magnetic separation, it simply or it exploits under what? Magnetic what? Properties. Their magnetic what? Properties. Those are based on the what? Magnetic what? Properties. That is how we undergo what? Magnetic what? Separation. Then the next one we have again is what? Chromatography. So it's important I put in our chromatography. Chromatography. So when it comes to the chromatography, the property it exploits is one. It's based on their what? Speed. It's based on their what? Speed. It's based on their what? Color. When you hear color, when you hear ink, when you hear pigment, and when you hear what? Dyes. When you hear what? Dyes. I was supposed to find matter for this person. And when you hear what? Dyes. So that is how you know that okay, chromatography is what needed for this what? Separation what? Technique. We also have what is known as what? Centrifugation. 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 So for the centrifugation is based on the different what? Density or what? Their particle what? Mass. So we say what? The density or what? Particle what? Mass. So there are differences in what? Particle. The differences in what? Particle mass or what? Density is when we use the word centrifugation. So the centrifugation is simply what? The spin. So when we spin, let's say we get what? A solution, right? We get a solution. Example, let's say a blood. We get our blood and want to get our what? Plasma from the what? Serum. So what we simply do is the what? We what? Spin at what? 3000 RPM for what? 5 minutes, and that is how we can be able to separate the what? Plasma from the what? Serum using what is known as what? The centrifugation. So that is just it. We have also our evaporation to dryness, which is what? Heat what? Resistance. We have our evaporation to dryness, which is what? Heat resistance. I'm alive. So we have our what? Heating to dryness, which is what? Example is what? We have our salt, which I have already given you an example based on what? Heat. So let's move on immediately to the differences between what? A compound and what? A mixture. The differences between what? A compound and a mixture. That is what I will just what? Give you immediately so that you will know it. And from there, we are moving on to the next topic, which is known as what? The particulate nature of what? Matter, chemical formula, and equations. And lastly, we end with what? Laws of what? Chemical what? Reaction. So let's just talk about the differences in so that when you hear about what? A compound and what? A mixture, you will automatically get the what? Differences. So a compound, so we say compound. We say compound and we say what? Mixture. We say compound and we say what? Mixture. So for a compound, please note, a compound is always what? Homogeneous. Homogeneous. A compound is always what? Homogeneous, while a mixture, take note, a compound is always, emphasis on the always. A compound is what? Always what? Homogeneous, while a mixture can be what? Homogeneous or what? Heterogeneous. Mixture can be what? Homogeneous or what? Heterogeneous. So the difference between a compound and a mixture is that compound must always be what? Homogeneous, while a mixture can be what? Homogeneous or what? Heterogeneous. That is for number one. And number two, we have I just pray this marker can carry me, so I'll go and buy marker. We have for compound can always, or a compound is supposed to be represented by what? A formula. A compound is always represented by what? Formula. Represented by formula. While a mixture cannot be what? Expressed. Cannot be what? Expressed. So there's a particular question JAMB like asks. It says, what is the difference? That is a compound and that is a mixture. They say sand. Sand is a what? Sand is a dash. And soil is a what? Dash. So it is very important that you would understand from this concept of what a sand is and what a soil is. Sand is what? Sand is what? A compound. Sand is what? A compound. A sand is what? A compound. While soil is what? A mixture. Although I can't actually remember the formula for what? A sand. But note, sand is made of what? Aluminium. It is made of what? Magnesium. And it's also made of what? Silicon. Although I can't actually put in the exact what? Formula. But always note that sand is a compound and soil is what? A mixture. Please take note of what? This. Also, in a compound, that is number 3. In a compound, constituents lose their what? Individual what? Identities. Or yes, their individual what? Identities. When they come into what? Mixture, or when they come into what? Formation, they lose their what? Lose their what? Individual identities. They lose their individual what? Identities. Identities. So when different elements come together to give us what? A compound, they lose their what? Individual what? Identities. Rather, they now function together as what? A compound. But when it comes to mixture, each of these elements coming together to mix still retain their what? Individualities. So what that simply means is that they still retain their what? Individual what? Identities or their individual what? Property. So they say what? Retain their what? Retain their what? Individuality. So when it comes to what? A mixture always retains their what? Individualities. So that is simply the basic differences I can give you between what? A compound and what? A mixture. One of the questions I saw in, I can't find it here, but I know I saw the question. The question was based on float water. It's asking us, is a float water a compound or what? A mixture, something like that. Yes, is it homogeneous or what? Heterogeneous? Any how they will put it. You understand? So the moment you are, whether they say compound or mixture, heterogeneous or what? Homogeneous, you already know that float water cannot be what? Homogeneous. Homogeneous simply means they are mixing together. But float water, you can see that this marker can be what? Floating on the what? This duster can be floating on a float water. Anything can float what? On top of what? A float water, and it is not what? Mixing. So automatically they are what? Heterogeneous. And this duster, despite the fact that it's going to float in what? A water, still retains its property as what? A duster, because I can pick it up and still use it to what? Clean the what? Board. So that is simply the what? Differences. So we'll move on to now to the next topic, which is what? The particulate nature of matter, chemical formula and equations, and law of what? Chemical what? Reactions. So that is what we'll be moving on straight to. So let's clean this. Alright, so let's continue. An element X, that is the next question. An element X forms the flowing compound with chlorine. Forms the flowing compound with chlorine. a particular element known as what X forms the following compound with chlorine. So let me give you the compound. The first compound is what? XCl4. That is the compound that it forms with chlorine. XCl3, and XCl4. XCl4. So this is the following compound that this particular unknown element known as what? X forms with chlorine. The question is, this compound formation illustrates A, the law of multiple proportion. A, law of multiple proportion. Law of multiple proportion. B, law of chemical proportions. Law of chemical proportion. Law of chemical proportion. C, law of simple proportion. So we say law of simple proportion. D, law of conservation of mass. So we say law conservation of mass. Law of what? Conservation of what? Mass. And E, law of what? Definite what? Proportion. E, law of what? Definite what? Proportion. Law of what? Definite what? Proportion. So it says an element X forms a what? Following compound with chlorine, XCl4, XCl3, and what? X what? Cl what? 4. So this is XCl2. So the question here is, which law or what is being what forward there? So let's simply see how we can be able to what break this word down. Let's see how we can be able to what break this word down. Alright, we have our X. Let's write our XCl4. Like we'll pause this live. Let me see. I can pause this live to. Hello, Gospel. Yeah, the one that I wanted to respond to the person. Full HD. Someone is saying full HD. I hope you can see what I am doing on the board. Are you the one that is watching live? No. Okay, someone is watching live. All right. All right. So let's see how we can be able to get this. We are going to cut this live short so that I can say I can go and buy marker and probably resume again. So this is what we are going to solve, and we'll cut this particular live short. So let's say fluoride. We have our fluoride, which is what? XCl4. We have our what? XCl3. And we have what? XCl2. So let's check the proportion. So we have our proportion. That's our simple proportion. The chloride is what? 4, right? We have our proportion. The chloride is what? 3. And we have our proportion. The chloride is what? 2. So from this simple proportion, we have 4:3 and 4:2. The answer here is what? A. Law of what? Multiple what? Proportions. The answer is what? A. The law of what? Multiple what? Proportion. So that is just how we would eat. I don't know whether you are seeing the board. That is the problem I'm having. All right, you can see the board. That is it. So if you can actually see the board, let's see how we can probably solve 1 or 2 questions again, 2 random questions, and we will call it a ending for this live stream. Call it an ending for this live stream. Let's see how we can be able to solve 1 or 2 questions. Let's see how we can be able. Let me look for a question that is here. Let me check for a question. Are you the one that is live? No. So this person is speaking. All right, let me look for a question that is here. All right, currently right now, I want to go and get marker because the 2 marker I got here is not actually working. So this is just, you have been able to solve some questions on the nature of matter, and we are currently asking questions on chemical reactions, that's the topic, that is particular nature of matter, chemical formula and equations, and the law of what chemical reaction. We'll be back shortly, so just stay tuned, and I believe you put the one that we have learned into practice. And if you have any questions, please don't hesitate to drop it in the comment section. I will answer each clarifications, and if you need more clarifications, feel free to demand from my WhatsApp number. I will drop my WhatsApp number in the comment section. Chat me up on WhatsApp, and I will be there to guide you. Note that achieving your dream JAMB score is very, very achievable. So until I see you in my next stream, I really love you. Thank you. Hey, clapping. Oh my, this mark, oh my.